Welcome to an example in which we have a pretty complex function here. Let me do it in layers. Minus 9 cosine, that's the outermost layer. Cosine, that's going to be the second layer. And x to the 8, that's the inner layer. There's three layers. I'll call it layer A, layer B, and layer C. It's important for you to know that this is not functions multiplied. You might go, it means cosine times x to the eighth. No, 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 no. Remember, this is if you think that, you're going to get it completely wrong. This is not cosine times cosine times yeah, sorry. It's not cosine. It does not mean cosine times cosine times x to the eighth. No, no, no. It's not multiplication. If it was, we'd have to use product rule. That's not what it is. What is it? It's it's inside. This is the inside of that function, which is all inside of that function. It's nested functions inside of one another. It's like the old Russian dolls they put, I don't know if you've seen those in dolls inside of dolls inside of dolls. It's an old Russian toy. Anyway, so it's nested inside. So we're going to use chain rule, not product rule. This is not functions multiplied. There's no product here. This is functions inside of functions, right? See that now? See how this is, oops, that's not what I want. See how this is inside? That's not multiplication. You might wonder, well, how do we know that's not multiplication, Mr. Heron? Well, because any function, f, if I write f of x equals 3 plus x, and then I put a 2 in there, you know that 2 gets plugged in right there. 3 plus 2, it's 5, right? So it means plug in. How do you know that doesn't mean multiply? Well, that's any number, anything in parentheses right after a function always means plug in. It doesn't mean multiply. Now, what if you put a number in the front? What if you go 3 times? Yeah, well, then that means multiply. That means multiply the front by 3, multiply the front by 3. Now the answer would be 15, wouldn't it? So anything in front of a function means multiply. Anything in the parentheses after a function means plug into that function. Well, sine, cosine, tangent, secant, cosecant, cotangent, they're all the trig functions are functions. So whatever comes after in the parentheses after a sine or cosine tangent, that's plugged into this. And then all of this is in the parentheses after the first cosine. So all of this is plugged into that. And then this minus 9, that is multiplied. Is that making sense? Whatever's in parentheses after a function, FGH or sine, cosine, tangent, whatever's in the parentheses afterwards, that's plugged in. It's not multiplication. So we got to be clear on that. Okay. So then that means we need the chain rule, don't we? So we need the chain rule when we have functions inside of functions. How do we do it? Well, let me make sure we're clear. We have A as the outer layer, and we have B as an inner layer, and we have C within that. So how do we do the derivative in that case? Well, what you do is you do the outer layer derivative first, and you keep everything else inside of that the same. So B, let's see, C, times, and that's like that outer layer is done. Now it's B's turn. B prime, his derivative. Keep the inside stuff that comes after him the same. Now he's done. Final layer times C prime. Right? They all have their turns, layer by layer by layer. We do the outer layer, A prime, keep the inside stuff the same. Do the second layer, keep what's inside of that the same. Do the final layer, all multiplied together. That's the chain rule. So let's do that here. So to do the derivative, oops, purple color here. So to do the derivative, I got to do the outer layer first. How do you do minus 9 cosine? Well, the derivative cosine is negative sine. So you know what I'm going to do? I don't want to make this too messy. I'm going to put sine and I'll change that to plus because that cosine became negative sine. Remember, the derivative of all co-functions is negative. So that cosine is negative sine. That changes that to plus 9. Okay. Keep the inside unchanged, which means cosine x to the eighth. Let me scoot that over. Doesn't change at all, right? Do the outside, keep the inside the same. Next layer, now do b prime. So now it's this guy's turn. It's his turn. What's derivative cosine? Again, negative sign. So this is going to be um, negative sign. Keep the inside unchanged, right? Keep the inside unchanged. Times the derivative of the final inside. Derivative right there. And these are all derivatives. What's derivative of that? 8x to the 7th, right? You bring down the 8, lower the power by 1. And this was a derivative here, and this was a derivative there. And that's basically it. I mean, you can clean it up a little bit if you want to. Here, I'll do it. But if you just type this in, it'll take it. But I'll clean it up if you want. So this 8x to the 7th and this 9 and this negative, these are all just multiplied. Well, maybe I should help you see the structure. Make sure you're seeing this guy is one piece, inseparable. How do I know? Because sine, whatever comes in the parentheses after sine, must be his plug-in. That's all plugged in. And cosine, what's after him, must be plugged in. So this is all one big triple nested function. And this is a big function. And this is a plain old number, and this is a plain old, I mean, number with letter and number. So I can multiply, um, therefore, this number, this negative sign, and this all together, right? These three, 9 times 8, and the negative is negative 72x to the 7th. You see that? 9 times 8, 72, the negative sign, and x to the 7th. And then everything else just as it is. Sine of cosine of x to the 8 times sine x to the 8. That just comes down there, and that just comes down there. And that's as clean as it's going to get. And that's how they did it. Minus 72x to the 7th, sine of cosine x to the 8th times sine x to the 8th. There it is. That's triple nested chain rule. That's challenging. There we go.